So on number 1, they want you to put it in exponential form. And since it's log base 11 of 1 over 21, that means that 11 is the base, and the answer to a logarithm question is the exponent, equals the answer, which is 1 over 121. Here we're going in reverse order, so we have log base 13 of 1 over 169 equals -2. And if you're afraid you put the numbers in the wrong place, just key that in your calculator and it should equal -2. So this next one, you have to have it in the same base. And I see that this second one is base 9, so I'm going to change the 1 over 81 to 9 squared, and then to the -2a. Well, then to move the 9 squared upstairs, because it's got to be on the same level, it would be 9 to the -2 to the -2a equals 9 to the -3a. So that gives us 9 to the 4a equals 9 to the -3a. That means 4a equals -3a. And when I add 3a to that side, I get 7a equals 0. So a equals 0. And in this next one, I see that there's a base 4 and 16 is 4 squared. So you have to change it in an exponential way. You can't do like 2 times 8 or 4 times 4. You have to put it exponentially. So 3n minus 1 is the left side equals 4 squared. Now you have the same base, and you just make 3n minus 1 equal to 2. So 3n equals 3, n equals 1. So here we have log of this mess equals log of that mess. So we can just make the two messes equal to each other. And I always like to put the biggest a squared on the left. Plus 2a equals 3 plus a squared. And you move everything to the left side of the equation. So you're going to have a squared when you subtract a squared from both sides, plus 2a minus 3 equals 0. And what times what is -3, and added together is 2. That would be a plus 3, a minus 1 equals 0. So when you make each of those equal to 0, you get a equals -3 and a equals 1. And you just need to make sure that the -3 isn't going to make the thing negative. But -3 times -3 is 9, and 9 plus 3 is a positive. And here 2 times 9 again is 18, minus 6 would still be positive. So in this case, they're both valid answers. In the next one, we'll put the p squared on the left, plus 51 equals 15p minus 3. When we move everything to the left side, we get p squared. Always put the p in the middle, minus 15p plus 54 equals 0. And you say to yourself, what times what is 54? And added together is -15, and that would be minus 9 and p minus 6, because -9 and -6 is 54, and -9 plus -6 is -15, and that equals 0. So in this case, p equals 9 or 6, and both of those make the equation true. So they're both right. You just plug them back in to make sure they both work. Sometimes they don't both work. Next one says log base 4 of -x plus log base 4 of 9 equals 3. When you have a plus, you change it to 1 log of base 4, and you multiply, let's go back here, 9 and -x. That gives you -9x equals 3. Well, we don't have a log on both sides, so we have to put it in exponential form. So that would be base 4 to the 3 equals -9x. 64 equals -9x. You divide by -9, and you get that x equals -64 over 9. And when you plug that back in here, a negative is a positive, so it's going to work out. So here we have a negative. So on the left, we change it into 1 log, and we put the numerator as the first guy and the denominator is the second guy, equals 5. But there isn't a log in both sides, so we have to change it to exponential form. So 3 to the 5th equals x plus 6 over x. So that's 243. Sorry, 243. 243. X equals x plus 6, which means 242x equals 6. We divide both sides by 6. When we divide by 242, and reduce the fraction, we get that x equals 3 over 121. And that is the answer. So here you have a plus, so you also have a multiplication. So you change it into one log base 2. Of 6x squared, you multiplied the 2, and 6 times 7 is 42, equals log base 2 of 66. Now you can go ahead and put that 6x squared plus 42 equals 66, because you have a log on both sides. When you subtract 42 from 66, you get 6x squared equals 24. Divide by 6. X squared equals 4, and to leave the x alone, you square root both sides. When you square root to leave an x alone, you have to consider the plus and the minus. So x equals plus or minus 2. You have two answers here, and they both work because when you put a minus 2 and square it, it's still going to be positive, so you're not going to have a problem. The next one, you also have a division one because it's you have division because it's minus. So log base 6 of 5x squared over 2 equals 5, but there's not a log on both sides, so you have to change it to exponential. And you have 6 to the 5th equals 5x squared over 2. So 6 to the 5th is 7,776, and when you multiply that by 2, you get 15,552. And equals 5x squared. We divide both sides by 5. So what we have to do is factor that 15,552. And we already know that it's going to be 6 times 6 times 6 times 6 times 6 times 2. And when you have that, you have 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, and a 2. So we're going to be able to take out 1, 2, 3, 4, 5, 6, 3 2s, so that's an 8. And we're going to be able to take out 1, 3, 2 3s. And that's a 9, so that's 72. And the square root of 3 is left over square root of 5, because we're going to square both sides. All right, so now we have to multiply by square root of 5 upstairs and downstairs, and you get plus or minus 72 root 15 over 5. So here we're going to expand, and I'm going to give that 4 to everybody, so we have log base 2 of x to the 4th over x to the 12th. Y to the 12th, because 4 times 3 is 12. And that means if it's division, it turns into subtraction, because we're expanding. Log base 2 of x to the 4 minus log base 2 of y to the 12. But when we have an exponent there, we can put it on the front. So that would be 4 log base 2 of x minus 12 log base 2 of y. And that's your final answer. Same here, you have an exponent, so that goes on the front. 4 log base 2 of x. And since it's division, it's minus 5 log base 2 of y, because the exponent goes on the front if you look at your rule sheet, and division turns into subtraction. Now we're going to condense, so this would be log base 3 of x to the 12th minus log base 3 of y to the 4th. And when you condense, you change it into 1 log base 3, and it'll be x to the 12th over y to the 4th. And that is your condensed answer. Number 14, I remember having on the test. I like to move this out as 1/3 log of x plus 1/3 log of y plus 1/3 log of z. And then you can take the log of x to the 1/3 times y to the 1/3, because all the pluses turn into multiplication. You turn it into 1 log. And anything to the 1/3 is the cube root. So this is log of the cube root of x, y, z. I would technically take that answer, but this is the best answer. It's more condensed. So this one you have to play around with and factor it. And I divided it by 12 because I see that there's a 12. And I came up with 12 and then another 12 and then a 8 and a 5. And so it all works out. You don't need to use the log base 9 of 9. But remember I asked you to add log base 9 of 9 equals 1 because 9 to the 1 is 1. But we don't need it on this one. So this would be the log base 9 of 12, which is 1.1, plus 1.1 again, plus the log base 9 of 8, which is 0.9, plus 0.7. So the answer would be 3.8, because it would be the log of each one of those. So this one would be log base 5 of 1 minus, and 240 is log base 5 divided by 5. So log base 5 of 5 plus log base 5 of 8 plus log base 5 of 6, because 8 times 6 times 5 is 240. But since the 240 is in the base, we're going to subtract all of those. Well, log base 5 of 1 is 0. What exponent do I have to put on 5 to get a 1? And that would be 0. Log base 5 of 5 is 1. And all these are going to be subtracted, because when you have a subtraction out here, you distribute it. So minus 1.3 minus 1.1. And we should get minus 3.4. Yep. I remember you guys love these. So in this one, the first thing you're going to do is switch the x with the y and the y with the x. And you're going to add the 10 to both sides. So you get x plus 10 equals log base 6 of y to the 4th. But that 4 can go on the front here, okay? And so I'm going to divide both sides by 4. And it would be 6 to the x plus 10 over 4 equals y. And they have it as 6 to the x plus 10, and then 1/4 out here, which is the same thing. I would take either of those answers. Here we do the same thing. We take the x equals 7 log base 3 of 4y. And then we divide both sides by 7. And then we just put 3 to the x over 7 equals 4y. But then you have to leave the y alone by dividing by 4. And you should get that y equals 3 to the x over 7, put a 7 there, over 4. Same with this one, would be x equals log negative 3y to the 4th. And so we have that the base, when there is no base, it's 10. So 10 to the x equals negative 3y to the 4th. and divide by -3. And so we have 10 to the x over -3 equals y to the 4th. And what we want to do on both sides to get rid of that 4th is make it to the 1/4. And that'll bite the dust on the right, and it'll be y equals 10 to the x over -3 to the 1/4.